right, at this point, we're going to assume that life is already here. But as a reminder, the first life forms on planet Earth were not dinosaurs. They were not sharks or anything approaching that level of complexity. The first life forms were bacteria. They were prokaryotic cells. Recall that prokaryotic cells are small, they're only about 1 to 10 microns. They're relatively simple in that these cells lack membrane bound organelles. So you don't see a nuclear envelope surrounding the bacterial DNA, which is circular and just floating around in there all willy nilly. There's no mitochondria, there's no chloroplast, there's no endoplasmic reticulum, no Golgi apparatus. So, relatively simple, at least compared to multicellular life forms today, but revolutionary at that time, and still mighty to this day, as prokaryotes represent both the oldest as well as the most widespread life forms on planet Earth. Two out of three of life's domains consist of the prokaryotes. The eubacteria, EU bacteria, often see it referred to as that, which is the true bacteria. Here in yellow is the first of those domains, and then the archaea, which is in orange. We recall from our classification learning activity that the archaea, many of them are extremophiles. So they're not true bacteria. They are as genetically distinct from bacteria as we are from bacteria. In fact, the newest and most comprehensive phylogenetic tree of life that's based on thousands upon thousands of genomes actually puts the archaea right down here, much, much closer to us in the eukaryotes than they are to the true bacteria, the very first life forms. Thus far, the oldest fossils yet recovered and definitively identified as having a biotic origin on planet Earth are the stromatolites, the oldest of which radiometrically date at 3.5 billion years old. They're found in what's known as Hamlin Pool in Shark Bay in Western Australia. You remember Western Australia also produced the 4.4 billion year old zircon crystals, the oldest rocks on planet Earth. So these stromatolites are akin to microbial mats. That is to say, layer upon layer upon layer, sheets of microbes that over vast stretches of time form these mounds, which in this case we've cross-sectioned it, and you can see these microbial mats layered upon layered, almost like sedimentary rock. But each layer is formed from single-celled prokaryotes. More precisely, these stromatolites were created by photosynthetic cyanobacteria. So microbial mats most likely represent the earliest forms of prokaryotic life on planet Earth. Again, a microbial mat is just a multi-layered sheet of prokaryotes that includes both bacteria as well as the archaeans. The first microbial mats were probably not photosynthetic cyanobacteria like we find in Western Australia, but they probably obtained their energy from chemicals found near hydrothermal vents in a process known as chemosynthesis. They're actually converting sulfur compounds into energy. And we still find these microbial mats around hydrothermal vents operating today.